So thanks. I'm really happy to have you to talk to you about the innovations that Red Hat has been doing with Kubernetes and OpenShift and how OpenShift is much more than Kubernetes. A little bit about me. So I'm a senior solution architect with Red Hat. I work in the financial services sector. I sound a little bit old when I say this to myself, at 30 years plus experience in software engineering and architecture. Started with embedded systems way back, radio communication systems, but prior to Red Hat, about 10 years in banking and finance. And yeah, when I'm not at Red Hat, I'm generally thinking about mountains, climbing them, navigating them, or just reading about them. So Red Hat has been laser focused on to deliver awesome technology outcomes for companies. We're continuing to deliver that trusted enterprise Kubernetes platform. It's used by over, I think it's about 1,300 customers worldwide. We're extending it with powerful new powerful new capabilities to stretch that into any cloud and provide that cloud-like experience. And we're continuing to enable teams to innovate and deliver awesome solutions. We're helping customers do just about everything, right? From modernizing their legacy applications in fortress data centers to building brand new web applications, new architectures with cloud-native self-healing architectures, and multi-cloud, being able to stretch out into the clouds. We're also enabling a whole bunch of new workloads like big data, analytics, AI ops, and machine learning as well. More locally, ANZ Bank are increasing productivity and taking cost out of their technology business with OpenShift. These numbers are actually an order of magnitude out of date, and these were just from April this year, right? So 300 to 400 containers running in OpenShift in ANZ Bank. They've got 98% improvement in deployment times with no downtime, so they're able to leverage this blue-green deployment model brilliantly with OpenShift. And 6,000 hours saved per annum through the productivity values of OpenShift. So, ANZ are really getting more out of every IT dollar that they're spending, and they're delivering more and doing it faster. But doing containers right and doing Kubernetes right it's hard, okay? And we see a few companies going down the path of rolling their own Kubernetes platform, and it's a great way to learn about the potential, understand the technology, and how that technology can add value to your business. But establishing an enterprise-grade, bulletproof platform for your enterprise is difficult, and it requires a number of components and things to be pieced together and tested and hardened for operations. Identity management would be a good example. If you're going to have a Kubernetes platform in your enterprise, you're going to put that into your identity fabric so that, because your customers are going to be connecting through this. Your staff, your back office, front office, developers, they're all going to be working with this platform and through this platform. So, you're going to need to integrate it into, your LDAP system. And that's going to require some knowledge of some quite complex components inside Kubernetes to do that. Or monitoring and alerting. I need to monitor these workloads or monitor the cluster. Okay, so I need to be with a monitoring solution, be able to alert with that and as well. And these are complex things. And that makes sense, right? Because Kubernetes is hard because it's a platform for building platforms. It's the beginning. Kubernetes is not the end game. Okay? So to make Kubernetes useful, but anything but the most trivial workloads, you're going to need infrastructure services, security services, service management services, and development services to go around that. Red Hat understood this from the beginning when Kubernetes was first made open source by Google. And we've surrounded Kubernetes with an ecosystem of components that turns Kubernetes from a generic container scheduler into a high productivity application platform that we know today as OpenShift. So how are we doing this? So next to Google, right, Red Hat is the leading Kubernetes contributor since day one, right? Red Hat completely pivoted over to Kubernetes once it was announced, and it's Red Hat's thought leadership in this space that is enabling Red Hat to make OpenShift so much more than Kubernetes. We work with open source projects all over the world, and to deliver this ecosystem of components. And what's special is our secret sauce is how we do it. You know, we take scores, hundreds of projects, and arguably nobody but Red Hat has done this as successfully, and take a project and then somehow we worked with that and we harden it and we make it enterprise grade so that you can trust it to run mission critical systems for your customers and for your business. So when the community declares a release of a project ready, right, we typically find hundreds of defects in that we work on, we fix, and then we put that back into the open source community. So when it comes to Kubernetes, right, Red Hat has done all the systems integration for you, so that you can have a bulletproof and robust enterprise platform. So Red Hat engineering has been focused on developing a much more opinionated version of Kubernetes with OpenShift 4. And because, as I've said, right, creating this enterprise-grade platform requires these parts, and managing all these components is complex. So, we've built this. We've got an awareness around the entire platform that we've done that because we've extended Kubernetes down to include the operating system with CoreOS. And we've brought Kubernetes up to include automated operations, the cluster management services, the application services, and the development services. And so what that means is, customers can spend less time on managing Kubernetes and more time building on it, right? And we've dramatically simplified the day one and day two operations through those automated operations layer that I'm going to talk about in just a minute. And which is because we've simplified that, it's going to dramatically take cost out of your technology run business. So, OpenShift, it's going to deliver all of the components that you need that are fully integrated to build and deploy and manage the platform. So, the engine room for OpenShift 4 is CoreOS, and that came out of Red Hat's Project Atomic and our acquisition of CoreOS, who had container Linux. And CoreOS is a minimal Linux distribution. So what this means is that it's specifically targeted to run container workloads. Unlike Red Hat Enterprise Linux or any other flavor of Linux, they're deliberately generic because they have to run a whole spectrum of workloads over these. And that means they've got lots of components in there that you don't really need. Now, the consequence of that is that that's an increased attack vector because there's components lying around there that you've got to keep current, right? So, excuse me. And with CoreOS, all of the services in the operating system are actually running as containers, right? Which means that it actually simplifies how you update that. And I'll talk about what we mean by over-the-air update in a minute, but it means that we can actually update the operating system a lot more simply. And most importantly, out of all of these, right, is CoreOS is an immutable operating system. And by immutable means it can't change. So it's kind of like your toaster, right? Your toaster, you plug it in, it always works. Well, generally works, unless you blow it up. But it's so if the operating system is configured with this ignition-based workload that spins it up, and then once it's configured as it is post-installation, that's it. It can't change unless it's via the proper update mechanism. So you don't get configuration drifting into the cluster. Unlike, we know today, right, if you are running clusters for any workload, over time, different operating systems have subtly or significantly different configurations creep into them. And if you're managing multiple clusters, those configuration differences across the clusters can start to create unpredictable outcomes. But also, right, if you think about from a support perspective, like Red Hat support, we've got 1,000 customers with multiple clusters, and if every customer has a different configuration across there, that makes it harder to support as well. So CoreOS being that immutable layer is going to make it easier for you to have a predictable, reliable platform, and also make it much more supportable. So from an installation perspective, let's have a bit of a chat about that, right? So on the left here, right, what has happened in the past is you lay down the infrastructure layer. then you lay down the operating system, and then you lay OpenShift on top of that. And then the operating system and OpenShift are then upgraded and patched independently of each other, right? But at the same time, when you're doing that, you need to manage the consistency between those two, right, which can become problematic. With OpenShift 4, by making the operating system and OpenShift as part of the one thing, then it means what happens is the installation experience is we lay down the infrastructure layer, so we're talking to the infrastructure provider to lay that down. It lays down the operating system and then OpenShift on top of that, and then the two are maintained together via these things called operators that I'll talk about in a minute. Now, before I move on to the slide, you'll notice that OpenShift 4 is still on the left-hand side there. That's just an installation choice that you have with 4, that you can make the worker nodes use that model still, or you could go for the other option of using CoreOS for both the masters and the worker nodes. So the updating of OpenShift is powered by operators. Now, operators is another awesome invention that came out of the CoreOS acquisition. So operators automate day 2 management. But what we mean by that is they codify the operational knowledge and all of the workloads that will automate the complete software asset lifecycle of a component, whatever you want that to be, whether that's the operating system or OpenShift or your application that you may be running yourself. Excuse me. So what it means is, so an operator is like a site reliability engineer in a box, is one way to think of it. And so it's going to manage, how do I deploy this thing? How do I upgrade it? How do I patch it? The operator takes care of that. And it also means that you need a lot less skills, right? So, which is great because it starts to help with the skill shortage that we have across the technology business. So, operators, they'll check, is the cluster healthy? And if the cluster's not healthy, they'll be able to fix that. They'll be able to implement things like security policies. Maybe you've got OpenShift sitting in a certain pattern in a perimeter architecture where you need to deal micro-segmentation across those workloads. Now, you don't want to leave the chance that someone relaxes that policy and introduces security vulnerabilities for you. So operators can automate those sorts of things and keep them current. And finally, you might want to have it like a database as a service experience, so something like a Postgres, and I'll talk about this later, about the whole experience for databases that can be powered by operators. So really, operators are going to simplify how you're going to run your core applications on top of Kubernetes and OpenShift. And to have this embedded knowledge is really important for making all of this easier to use, this Kubernetes thing. So maintaining software currency is a problem for any software business or any technology business. And so over-the-air updates are provided and they're enabled by these operators. And by over-the-air update, what I mean is that the operators will call back to Red Hat to see what's available and download that if there's an upgrade or a patch available there, and then be able to automatically install that. And what's nice about it is that the operators got baked into that to say, are all the preconditions in place for me to be able to successfully deploy this? And if they're not, the operator won't do it, right? That's all part of the site reliability engineer logic that's built into these operators. Now, of course, you've got to, in any organisation, you've got to deal with change control. So there's checks and balances to make sure that the cluster's just not going to be changing itself all the time. So there's manual innovation steps there. But of course, you could also do an auto update if you wanted to. One final thing about the operators is that they're smart enough to work out if they can skip intermediate updates, right? So maybe something hasn't been updated for a little bit and you're a couple of updates behind, and the operator will be smart enough to know if it can actually skip those intermediate updates, which makes it easier. And again, this is all about making that Kubernetes thing easier. So operator hub and certified operators. So, installing services in a platform is difficult, right? And often you're downloading YAML files from GitHub or whatever and trying to deploy these things into Kubernetes. So what we're trying to do is make it easier for installing and managing your applications there and making things available across the cluster. And it's also going to mean the Operator Hub, which was released by Red Hat, AWS, and Google and Microsoft earlier this year. It's a central place where people can come and publish the operators they have. So, for example, Dynatrace have put an operator up there for how I can deploy Dynatrace into OpenShift, or Prometheus that we'll talk about a little bit later, right? I can have an operator for installing Prometheus across the cluster, or a service mesh, or Crunchy Data's database, or Kiali, whatever it may be. So the Operator Hub is a place where you can go and get community-built operators in there. But also in OpenShift, we've got an embedded Operator Hub. And the value of that to you is that of all of the things you can get to install these services onto your cluster, that they're certified operators, which means they're also supported by Red Hat. Okay, so, unlike if I go to the public operatorhub.io, right, and if I want to build a service mesh, I'll have to, put in the Istio operator, the Kiali operator, and the Jaeger operator, and then have to kind of plumb this thing together with a few other components. Red Hat, that we released a service mesh just recently, which has all three of those, right? Istio, Jaeger, Kiali, and all of the plumbing you need behind that as a single operator supported by Red Hat, which gives you complete observability and traceability of all of your microservices. So, when we look at how all of these new technologies that we're bringing on top of OpenShift and how to make them available, the embedded operator hub is really what's going to make it easier for everybody to use. Administrators will have full control over what operators become available and what services become available on the cluster as well. And so when they'll select an operator and they'll work, do we want to make this thing available? And they'll also look at it and say, how much does this operator do? Does it only do install? Or does it also do upgrades? And they'll look at all of that and they'll say, are we going to make it generally available or just to this group over here? And then they'll make that available for people to use. And that's going to be a single control plane that's going to the way that they'll publish these things. From a developer point of view, what the operator console is trying to solve is, if I'm not a cluster admin, how can I deploy these things? So the console for the developers will be a self-enablement catalog, if you like, where I can go and select the services that have been made available through the embedded operator hub, and be self-enabled to deploy that. So I'll be able to go, gee, you know what? I want a service mesh. So I'll go there and I'll put that, and it will deploy that across my project. Or I want a MongoDB. Right, and it will be like a database as a service experience to enable that within the project. Ticketmaster, a great example there with the Prometheus operator. They've got 344 instances of Prometheus running across their cluster. That's a big deal to manage in the past, right? Because everybody's kind of pulling that stuff down, as I said, those YAML files, deploying it, damn, that doesn't work, tweak the YAML, deploy that again. The operator is a single place where any team wants the Prometheus operator by the way, Prometheus is just for visualizing time series data, if you don't know, so it's good for log visualization. And then they can basically deploy that into their project so that they can get that. And here's a real-life example, right? So, I want a PostgreSQL database. So, I can go to Docker Hub, and I get that, and, terrific, I've got this containerized database, but now what? Right? It's containerized, but, how am I going to back that up, right? And how am I going to, what about monitor that and get the observability of that? And how am I going to work out, what's the deployment rules about that? Is it cluster-wide or not? And so, the idea with the operator, right, we move, and Crunchy Data have done this with their operator that you can get, right, is it's created this SaaS-like experience that I was talking about, where it will, it's containerized. It understands how to configure the storage. It handles replication. It handles the backup. Handles automatically updating the database as it goes. And when it's backing up, right, you've got that question normally said, do I have to query the database before I back that up? That's baked into the operator. Right? The operator is going to do that for you. So it kind of takes you from a place of, I can pick up this piece of software and deploy it and then kind of work out what to do with it, to this place where all of the logic is built into the operator itself to do that for you. Taking it, looking a little bit further up the stack now, because I've really focused on the operational aspects of what we've done with Kubernetes and OpenShift, and looking at how we're enabling developer productivity. So, we need to try and get to a place where developers are are focusing, less on the lower value activities and more on the high value activities like, delivering code, right? So, self-service provisioning. So developers can get their workspace that they need straight from the platform. And consistent environments across, dev, test, prod to try and fix this, works on my system scenario. Automated build and deploy, right? So, source to image, which is, I check in this Java code. And OpenShift looks at that and goes, that's Java. I know how to compile Java. And not only do I know how to compile Java, I know how to containerize it. And not only do I know how to containerize it, I know how to deploy that. Right? So the whole source-to-image capabilities, which are really raising that level of abstraction up and taking away a lot of the infrastructure complexities away from the developers. CI/CD pipelines, so that are baked into OpenShift to take you through that whole process from checking in, running unit tests, whatever it may be. Configuration management across all of the namespaces projects and across the cluster. So secrets management, making sure my application configuration here is the same as over there. And then finally, application logs and metrics, because that type feedback loop for development is really important in order for them to be as effective as possible. So, and this is where OpenShift, right, before I was talking about how, we've raised Kubernetes up, this is where we come from OpenShift being an easy to maintain and operate container scheduler to a high productivity application platform. These kinds of features. There are 3 key developer productivity enhancements that we've released that I'd like to quickly talk about. One is code-ready workspaces, which I just love. It's a web-based IDE based on Eclipse, which OpenShift, which Red Hat open sourced, and it's a collaborative development environment and integrated development environment, fully baked into the CI/CD pipelines, hosted on OpenShift. So it means and it's for those who know Visual Studio Code, I've got the kind of that look and feel set up about it, but it's kind of a VS Code experience. You've got other skins you can put over it. But I need nothing more than a browser to do my entire software development lifecycle, right? Which is really, really awesome. Then there's OpenShift Do or ODO. And instead of, you've got like OCO or kubectl, as if you're using Kubernetes, which is like more working at the Kubernetes and the OpenShift operations construct. This is a command line tool that works at higher levels of abstractions that developers work at, like source code, connections, links, deployments, things like that. So so if you're a command line hero as a developer, it's a command line target at the types of activities that developers do, which is also really good for writing like, make files or for scripting, right? Because I can also write them at those levels as well. And then finally, if you're using an IDE with a thick client like laptop or whatever, we're supporting all of the major IDEs now, which means that you'll be able to deploy straight from your IDE. In fact, Visual Studio Code's OpenShift plugin is one of the highest downloads of all of the plugins for Visual Studio Code. I'd like to tease out a little bit more on code-ready workspaces and talk about some of the benefits, right? Because with code-ready workspaces, you're going to be able to accelerate your onboarding. So teams are going to be onboarded straight away. I've got that IDE straight away. I just needed that browser, and I'm up and running straight away. Consistent workspaces. Everyone's got an identical workspace, which means that, again, it's this works on my machine scenario is not going to hit you. And protecting source code, and this shows up in a couple of different, 3 different ways, right? So none of your source code will leave the platform. So the idea of these insecure developer laptops, right? You don't have to worry about that because all the source code is on the platform. And that also helps you because you need a lot less complex security controls if you've got remote workers, like working from home. You don't need to worry about VPN access, VPN clients on your laptops, things like that. It's a lot easier to set up a SAML access with a web client, right, than it is to set up all of that other infrastructure. And finally, you might have offshore development or third parties that are trying to deliver into your source code repository, which is a highly problematic task, right? Code-ready workspaces solves all of those problems. So kind of taking a bit of a left turn now, in terms of how do you consume OpenShift 4, right? Well, there's 3 consumption models that we have now. And the idea is we're trying to give a choice and balance the level of productivity and operational effort versus the level of control that you want. So, a self-managed is, you install OpenShift 4 on your bare metal, onto your hypervisor of choice, or into any of the public clouds that you want. And then you're going to look after and managing that cluster. OpenShift Dedicated is a managed offering managed by Red Hat at the moment on AWS, but shortly to Google Cloud, where we're managing the cluster for you in your VPC to your controls, right, to your security perimeter controls, etc. on that, right? So in there. And then finally, the new awesome release and partnership. I mean, whoever thought that, so Nadella would have been on the stage at Red Hat Summit, right, of all the things, announcing a Microsoft and Red Hat partnership like this. This is a jointly engineered OpenShift offering that you buy from the Microsoft marketplace, right? It's a Microsoft product, right, with Microsoft support, and was supported by Red Hat behind that for third-level support. And it's jointly engineered. And that's like, it totally blows my mind every time I see that, right? So, and so these consumption models, regardless of how I want to choose to operate, I can take advantage of this consistent platform that will run everywhere. And when it's running everywhere, I can use all of those special source features of every single one of those clouds, and take nothing away from those clouds, but have that common experience, which makes it so much easier for the enterprise. Now, earlier on in the slide, I didn't call it out, but maybe you saw it, right? 75% of companies saw complexity as a blocker for adopting Kubernetes and containers. As a response to that, right, so Red Hat, we just don't offer technologies. We've got services to back that up. And so, the Red Hat Container Adoption Program is the services that basically say, how can I get a cluster, OpenShift, into my organization and get that set up in a way, all of the supporting capabilities we need, the practices and the training for people to be operate that. And then there's the Open Innovation Labs, right, which is a real change catalyst, right, because it's targeted at your development organization, where they need to adopt new ways of working, new ways of thinking, new architecture practices. And so this is like a 4 to 12-week residency with pair programming with Red Hat engineers, working with the team. And the goal is, right, at the end of the residency, is a product is delivered. It's not just, it's the first iteration. It's meant to be, whatever. It's every release, every residency has releases that have business value. So, when we look at how customers are, or why customers are choosing OpenShift, it really is for that trusted enterprise Kubernetes. And, we've built this entire platform together from the CoreOS right up through the operations and into the developer experience there. And we're taking the variability out of running a DIY or many of the public cloud offerings here, and the multiple flavors of Kubernetes. And that cloud-like experience everywhere, right? Of that crunchy database. I can say, I've got this database, it's running on premise, but I need to move that workload over here. I know it's going to work the same over there. The operators are going to ensure that, and I can put that anywhere. So, it's going to be the same. So, and our ability to empower developers to innovate, right? And all of this is built on the power of open source and open source innovation. So, it's how all these pieces come together, right, which really emphasizes why OpenShift is so much more than Kubernetes. So, with all of that, please go and have a chat at the consulting booth to talk about maybe a monolith to microservices workshop that we can run, which really will help you see how you can go from your legacy applications, legacies overused, but monolithic workloads, and how you can actually modernize those architectures and run those in the cloud and on OpenShift. And hybrid cloud infrastructure booth. Go and schedule a discussion if you want to come and talk to me and find out a little bit more about what we've talked about today, or any of the team. Come and see us at the hybrid cloud infrastructure booth. But most importantly, I want you all to go away from here and tinker, right? And that, because this is the world we're living in and the time we're living in. I'd like you to go to openshift.com.trial, spin up. You've got 60 days to spin up your own cluster, to knock yourself out and really experiment with OpenShift 4 and try and really appreciate what it can deliver for you. And it's not just OpenShift 4 that's sitting there as well. There's also Eclipse, so you get that code-ready Workspaces experience as well. So with all that, thank you very much for your time and coming to listen to me.